Okay, hi guys. So today we're going to do this Codeforces Round 727 Division 2. And as you can notice, there's something new today. So I got this really bizarre idea of trying to make screencasts a little more interesting. And as you can notice, I think somewhere here that I have my heart rate right now. So it's like semi-live kind of thing. It's the number of beats I had in the last 1 minute. So yeah, it updates every 1 minute, and it's actually linked up to my fitness band that I have here, and it's connected to my phone, and that's connected to my laptop and so on. So yeah, the idea, the way I got this idea was sometimes when I upload screencasts to some contest, I think maybe during Kickstart or some Codeforces round, a lot of people were asking me how I stay so calm during contest, and I don't really think I stay really calm, but yeah, so this is like a good way to verify that. I mean, my average heart rate during this resting position, like while sitting, is around, I think, between somewhere between 70 to 80. So if it's like above 80, I'm a little not calm, and if it's below 80, then you can say that I'm calm. So yeah, what is it right now? Oh, it's above 100. Okay, yeah. So obviously, I'm always a little nervous while starting the videos, and I could actually meditate and bring it down, but uh, I like to be a little hyped up while I'm doing contests. That helps me be not sleepy, I guess. So yeah. But yeah, so as I think it should go down to a little normal while I'm actually doing the contest, but can't guarantee. I have no idea. This is like an experiment for myself as well. So maybe I'm actually calm during contest. I don't know. So anyway, so let's play a game. Uh, this heart rate updates every 1 minute. So what you have to do is you have to watch the video and you have to find all the timestamps where the heart rate was 69, and you have to comment that in the comment section. And the first person to get all the timestamps wins. Okay. And at any point, if the heart rate goes down to zero, that means the problem defeated me. Okay. So there are n people. Okay. Mhm. Okay, yeah. So the fitness band is making my hand a little heavy, so it's not that easy to kind of type with that. Okay, yeah. Okay, and then some for everyone, right? Okay, it's kind of like um, right. So it takes t seconds to finish it. So if like t is greater than x, then we can find how many haven't finished right now. Mhm. Okay. I think we need a case where x equals t to actually understand what's going on. Okay. Yeah, I think that's clear. So what we have to do is, I think t by x is the maximum of, wait a second. Okay, when they finish. Yeah. So when they finish, we want to see how many people actually started between that. I think that's t by x, right? So t by x is the number of people who have started in between, except for the last few people, because they will kind of form an AP there, because like when the last person finishes, obviously there will be no one who has started but not finished till then. So okay, so we have something like int answer equals 0, print the answer at the end. Okay, and Okay, so ideally we should add, I think, p by x n times, but what we will do is the last few people won't follow that, right? So I think ideally answer is like p by x for all the n people, but we have to decrease it for the last few people. For example, for the last one, the answer has to be 0. For the second last one, it has to be 1, 2, 3, and so on. So let's say val equals p by x. Okay. And the last one has to have 0, second last has to have 1, 2, 3, and so on. So what we will do is we will try to calculate the total number of people that are affected by this. And I think that will be just val number of people, because if value is 1, then only the last person is affected. So let's say we calculate the number of people that are affected. That is minimum of n comma the val, right? Because the last few people are affected, right? So obviously not more than all the people can be affected. And then the affected people will actually form an AP. Okay. So this will be like an AP of 1, like 0, 1, 2, 3, and so on. So the first term is 0 and the last term is affected, I think. No, the last term is affected minus 1, right? Okay. So I think the sum will be like n into n minus 1 by 2, something like that. So I think we can do answer equals answer minus affected times val. Okay. And then we can add affected multiplied by affected minus 1 by 2. I think that should work. Let's try 533 and this 199 thing. Okay, yeah, I think this works. Okay, explanations at the end by them. So, okay. Yeah, that worked. Love song. Okay, so song is a string consisting of n lowercase letters. Let's make two questions. Okay. Oh, right. Okay. 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 Right. I think we just need to know how many A's and B's and C's are, and all the characters are there in that range, and that should be enough. Okay. Yeah, that should be enough. Right. So this one is actually easier than the. I think this one is actually easier than the other problem, the A problem. Okay. Okay. So I have NQ, and I think I'll also need to have the string. Okay. And after that, I will have the queries. But before that, I need to have the right. So I need to find how many occurrences of a certain character are there in a given range. So for that, I think I can use prefix sum, like 26 prefix sums, something like that. Right, it should work. You could also use that vector plus binary search approach. I'm going to stick with this one instead. Okay. So let's iterate on this and say that, okay, so the prefix sum of I plus 1 sorry, this character. We need this character. So let's say int c equals si minus that a. Okay. So let's say prefix sum of c comma I plus 1 equals 1. Okay, because this character is present. And then we have to actually perform the prefix sum, right? So we can do something like J026. Okay. And then pf j comma I plus 1 plus equals pf j comma I. Okay, so now I actually have the prefix sum of any character, and now I can easily find the number of occurrences of any character in any range. So I have the queries, and each query is like L and R. Okay, right. So I do C in LR, and now I want to know how many are there between this range. Okay, so I think right. So we have something like answer to this query as answer that I will print here. Okay. And then in between, what I want to do is I want to count number of A's, number of B's, and so on. Let's say this is the character. C is the character. Goes from 0 to 10, 26. And I want to find the count that is present there. So I will find it. And once I find it, I will do something like answer plus equals I plus 1 multiplied by the count. By now I actually need to find the count for C. And that is like, I think, prefix sum of C comma R minus prefix sum of C comma L minus 1. I think this should work. Yeah, maybe this is it. Let's see if it works. Okay. 3821 is wrong. Okay, 3821 is wrong. Yeah, 3821 is wrong. So, okay. Right. For each question, print the length of the string obtained. So first of all, why is it 3 if uh, we have 2 A's and 1 B, right? Let's actually print the count. So let's print C space the count and see what we did wrong here. Yeah, we have 2 A's and 1 B. So this should give us 4, right? Because oh sorry, this is C plus 1. Yeah, makes sense. And now it should be correct. Yeah, 4, 7, 11, that's correct. 5, 4, 1, 5. Cool. And whatever this is. Okay, yeah, looks correct. Okay. I think my heart rate must be hiding a lot of the output, right? Yeah, not really. I can't really do anything about it. Even if I had it here, then also it would have hidden something important. Okay. So now we have this problem stable groups, and what is this about? Okay, so there are n students. They each have a level. You need to split them into stable groups, and it's stable if in the sorted array of their levels, no two neighboring elements differ by more than x. Okay. What is it? Okay, we have to form subsets. Okay, we have to form subsets of this set, and the minimum difference between them should be smaller or equal to x. Okay, cool. And okay, k more students are allowed. and we have to find the minimum number of table groups that the teachers can form. Okay. Mm-hmm. Okay, so the way I see it, if we sort the array first, then the subset that we are actually forming would just be substrings, right? So it would just be subarrays, in fact, contiguous subsegments, because no point taking something bigger, that would only increase x. So yeah, so first we sort the array, and then what we do is we want to find the minimum splitting point kind of thing. But we also have k, so we have to keep that in mind as well. Okay. Mhm. Right. So if k wasn't here, we could maybe, I think we could just do a binary search. Okay. Hmm. Okay. So whatever k students that we have would be used to just join two segments that are not joined already. So first we need to actually form the segments. And we don't even need binary search for that, right? That would be greedy. Like whenever the difference between two adjacent elements is greater than x, we have to split at that point. And actually, we only care about the difference between the split points. We will put that in our list, and we will try to merge them by using our case students that are there, right? Yeah, I think that's what we have to do. Okay. Okay. So we have nkx, nkx. Okay. Then after that, we can take the a as input. So something like this, I think. Okay. Then we can just sort this thing because that makes sense. Then we can have another vector in which I'll just place the differences between the split points. I can have something like I0, or let's say I1, and that means starting from the index 1 till the end. I will see the difference between I minus 1 and I. Okay, so let's say the difference is equal to AI minus 1. Okay. Now, if this d is, I think, smaller or equal to x, then we can just continue. Okay. Otherwise, we can put it in our vector. So we can put it something like v dot pushback d. Okay. In fact, instead of putting d here, maybe we can just put how many students we would need to actually fill this gap. So how many would we need to fill this gap? Right. So it depends on x, and it depends on the gap, obviously. It's something like if we have 10 and 20 and the gap is like 3, then after 10 we need to put one on 13, 16. Okay, right. So if the gap is like 10 wide, okay, then we need to put one on 3, 6, and I think also on 9, right? So I think it is just 10 by 3, because if we had like only 9, then we could just put, okay, it's not 10 by 3, something else. I think it's like 10 minus 1 by 3, like whatever, d minus 1 by x, I think that's what it is. Okay, because if d equals x, then it's just 0. If d is greater than x, if if d is just 1 greater than x, we can use just 1. And if d is equal to exactly 2x, like if x is 10 and d is 20, so then what we can do is we can just put 1 and 10, right? So we have 0 to 10 and 10 to 20. But if we had 21, then that wouldn't work. Because if you put in 11, then that's also wrong. Yeah. So I think it is just d minus 1 by x, right? So this is the cost that is required to actually merge them. And what we can do is we can just sort them, right? Because obviously it makes sense to merge the smaller one first. So let's say int answer equals 0. In fact, int answer equals the size of v, the number of splits that we have to make, plus 1, I think, because like obviously if you make one split, there are two groups. And now we want to see how many splits we can actually get rid of. So yeah, I'll decrease k that way. Let's say, yeah, we can do something like this for int x in v. Okay. So, okay. So if k is greater or equal to x, this is confusing. So let's take y instead of x. Right. If k is greater or equal to y, then we can say something like k minus equals y, answer minus minus, because we have decreased the split. That's it, I think. Yeah, that's all we have to do. And we can just print the answer again. And this should work. Let's see if it works. I have to bring the test cases right. Okay, yeah, it worked on both of the samples. So I think it should work on the final thing as well. Let's try. Okay. How much is my heart rate? Oh, it's pretty normal actually. I'm actually calm during contests. 79 right now. Okay. But if I get a wrong answer here, I didn't. Okay. So we have PriceFixed. Okay. How many submissions by the way? Is my rank like top 100? Yeah, top 100. Why is Galen Collins so... Okay. Anyway. So we have Lena is the most economical girl in Moscow. So when her dad asks us to buy some food for a trip to the country, she goes to the best store, price fixed. Okay. How is that best if the prices are fixed? Okay, yeah, so they can't overcharge. Right. Store has an infinite number of items of every product. So can't they just sell everything for free if everything is infinite? Like, okay, right, so how will they make money? All products have the same price, 2 rubles per item. And okay, for every product I, there is a discount for experienced buyer. If you buy BI items of products of any type, not necessarily type I. Oh, okay. Then all future purchases of ith product, there is a 50% discount. So you can buy an item of the ith product for 1 ruble. Okay. So if she wants to buy n products and she must purchase at least AI items of the ith product. Help Lena to calculate the minimum amount of money needs to spend if she optimally chooses the order of purchasing. Note that she wants she can buy more items of okay, if she wants she can buy more items of some product than needed. Cool, maybe that makes sense. But would that ever make sense? I don't think it will because it might. Like once you have something discounted, why not buy a lot of it? Maybe that will never help. Yeah, I don't think it will ever help because instead of buying an item unnecessarily, just buy an item that you actually require. So you will pay 2, but you save 1 here, right? So that makes no sense to buy extra. Okay, so we will only buy whatever is required. But yeah, so we want to get the discounts as soon as possible. But we also want the discounts to work when we get them. right? So what's the point of getting a discount when you, like, if you can't use them at all? So maybe the things that have the BI greatest, why don't we buy those first? Because like we're not very likely to ever get them on a discounted price. Okay, so the object that has the minimum BI, let's try to first um, have that one discounted, and then buy as many as we want of that, and then okay, then let's hope that the next item also gets discounted, and then buy as many of that, and then hope that the next item also gets discounted and buy as many as possible from that. Okay, right. So I think we kind of need to have this thing that we will buy the, like we will sort according to B, and then we will buy the items with the maximum B first, so that, because I know that that will become discounted the like at the latest time, right? So what I want to do is I want to buy those first, so that the earlier one gets discounted, and then I can actually buy it. Okay, so that's the whole idea, I think. I think I should zoom it a little bit. I should have done that earlier. Anyway, so okay. Okay, so I have to sort it like pair, I think. 25 plus 5. That's what I have there, and then I have PII. Okay. Okay. Like I could instead have something like, yeah, that's better. Okay. Okay. Yeah, that's better. PI dot second, comma the PI dot first. I'm taking the second first because I have to sort according to the first, which is B. Okay, so sort all PI, sort all P in fact. Okay, so now what I want to do is I want to have two pointers, like I equals 0 and more like start equals 0 and end equals the n minus 1. And what I want to do is I want to first get the start discounted. So this while condition should be something like while s is smaller or equal to e, I guess. Right. So now what I will try to do is I will try to see if I have the discount for the first element or not. So something like, okay, minimum sum. So let's say this is the answer that I will print. And I also need to have a variable named bought, which stores how many I have bought. Okay. So if the wait a second, right? So if the first element is already discounted, that means if ps dot fr, okay, if this is already greater, smaller or equal to the number of elements that we have bought, then what we will do is we will try to buy as many of these as possible on the discounted price. So we will do something like answer plus equals, wait a second. First of all, we will do something like bought plus equals like the amount of elements that we want to buy from here, that's nothing but ps dot second, right? And answer plus equals ps dot second again, right? Because we are buying it on a discounted price, so that is just one variable, right? I think that's it. But if we cannot have a discount for the first item yet, then we want to go to the last item, and we want to buy the last item at a discounted price, right? So let's say the required is like minimum of the number of elements that are required to get the discount. That is ps.fr minus the number of elements that we have bought, comma, like these are the elements that we require, but we cannot buy more than the number of elements that are present in the last one. So that will be something like pe.sc. Okay, so these are the number of elements that we have to actually buy. And right, so we will say bought plus equals required. By the way, here we should do s plus plus because now, yeah, now we have bought this completely. Okay, now, yeah, we have bought required more, and p.sc actually gets decreased by required, and answer gets increased by twice required because we have bought it on a not discounted price. And if pe.sc equals 0, that means if we have bought everything from here, then we could say e minus minus, because now next time we will try to buy something else. So this should work, I think. I hope that works. Reg, okay, that's actually REQ. Mistake. Okay, works on the sample. You have to submit. Kind of like a two-pointer approach, I would say. I have a pointer to the first and to the last. You could also use like a DQ here and keep on popping the elements on the front or the back. But yeah, that's the same thing. So yeah, I think what I did here is kind of like a doubly ended queue only. Okay. Anyway, so that was that. And okay, let's see the problem E now.